Euler-Cauchy Differential Equation. It is a special form of a differential equation where we have a variable coefficient. For instance, in this case, it is the nth order derivative of dependent variable y with respect to x. What is the coefficient of this one? That is a naught into x raised to power n. So this a naught is constant and there is a variable coefficient whose power is n. So if you observe, in this case we have taken nth derivative. It has a coefficient in a variable form x raised to power n. Next term is n minus 1 derivative of y and it has a coefficient as a constant times of x raised to power n minus 1. So again it has a variable coefficient in form of x and its power is n minus 1. So if you observe this term, this is the derivative with respect to x one time and it has a coefficient as a x whose power is 1. And the last term is y, and in this case we are not taking any derivative, so means it has no coefficient of x. If we have a differential equation of this form, such differential equation is called as a Euler-Cauchy equation. Let's understand with these three examples whether they are the Euler-Cauchy equation or not. So in the first case, we have the second order derivative and it has a coefficient as constant times of x square. So second order derivative, x square term is there. In the next case, first order derivative, x raised to power 1 term is there. No derivative, no x term is there. So clearly this is the Euler-Cauchy equation. What about the next one? In the next case, first order derivative and x coefficient is there, no derivative, no term of x. Again this is a Euler-Cauchy equation. In the previous case it is a second order Euler-Cauchy equation, whereas the second one is a first order Euler-Cauchy equation. Now what about the third one? So in this case, third order derivative is there. Do not directly say from here that it is not a Euler-Cauchy equation. Let's observe the next term. In the next term, we have 1 by x into y. Y means there is a no derivative, so there should not be any x. But it has a coefficient 1 by x. Now the point is, can you rearrange the term? And after that, we have Euler-Cauchy equation. Let's check it. So it has a 1 by x. We need to remove this one. So we can multiply by x to entire differential equation. So when you multiply by x, we have, this is 5 x cube third order derivative of y with respect to x plus x by x is 1 into y is equal to multiply also the right hand side term with x. So now check it whether it is a Euler-Cauchy equation. Third order derivative x cube, no derivative, no x, and right hand side is just a function of x. So it means yes, this is the Euler-Cauchy equation and its order is 3. Next point is how to find a solution of Euler-Cauchy equation. So in the first step, in right hand side function, that is your Rx, replace x by e raised to power t and this term x into the first order derivative of y with respect to x, that can also be written as x into dy by y, where d stands for the derivative with respect to x. We replace this term by theta into y, where theta is again a derivative operator, but it is a derivative with respect to t, where a d is again a derivative operator, what with respect to x. And if we have a term x square, second order derivative of y with respect to x, that is replaced by theta into theta minus 1 into y. And if we have a term x cube, third order derivative of y with respect to x, that is replaced by theta into theta minus 1 into theta minus 2 into y. And if it is a nth order derivative of y with the coefficient x raised to power n, in that case we replace this term into theta minus 1, theta minus 2 till n minus 1. Once you follow the step 1 and 2, we have a differential equation with a constant coefficient. Then we will use the usual methods to find the solution of differential equation whenever we have a constant coefficient. At last, that step is very, very important. Once you are getting the answer, replace t by log of x, that is evaluated as the value of t from here. Or if we have e raised to power x term, that is replaced by x. Understand how to apply these steps with the help of example. General solution of this differential equation. So first we will check whether this is the Euler-Cauchy equation. So we have second order derivative with a coefficient as 2x square. First order derivative, coefficient contain x term. No derivative, no term of x. So clearly this is the Euler-Cauchy equation. Now how to answer in this case? First we will take non-homogeneous function, that is the x cube. So we replace in this case x by e raised to power t, along with x into first order derivative is replaced by theta into y, and x square second order derivative is replaced as theta into theta minus 1 into y. Substitute these values in this differential equation. So we have 2 times of x square second order derivative as theta into theta minus 1 into y, plus 3 times of x first order derivative is replaced by theta y, minus 3 into y is equal to, this is a x cube, so x is replaced by e raised to power t power 3. So this is further is equal to e raised to power 3 into t. Now simplify the left hand side term. So from here we have 2 theta square minus 2 theta into y plus 3 theta y minus 3y is equal to e raised to power 3t. This can further be written as 2 theta square minus 2 theta plus 3 theta y, that is plus theta minus 3 into y is equal to e raised to power 3t. So we have collected the coefficient of y and resolved this factor minus 2 theta plus 3 theta is equal to theta. Now if we check it, in place of theta, if we have this form, in that case we are finding auxiliary equation to find the complementary function, and particular integral is evaluated in form of 1 by fd e raised to power 3x form, and where exponential case d is replaced by a. The same procedure we are going to follow over here, but instead of d it has theta, and instead of x we have t. So rather than writing the answer in a yx form, we will write the answer in a yt form, because theta is an operator, that is a derivative with respect to t. From here we need to find the complementary function. For complementary function in terms of a t variable, we will write the auxiliary equation. Auxiliary equation is, in that case we are replacing d by m, and same in this case we replace theta by m. So 2m square plus m minus 3 into y is replaced by 1 is equal to 0, because the complementary solution is corresponding to the homogeneous case. In that case we are writing is equal to 0. Now what are the roots in this case? Roots are m is equal to 1 and minus 3 by 2. Now, if we have two roots as a real and they are different, in that case, complementary solution is written as c1 e raised to power x, now x is replaced by t, plus c2 e raised to power minus 3 by 2 into t. So we have evaluated the complementary solution. Now we need to evaluate the particular integral in order to find the general solution. So particular integral, for that case we will create in this form. So ypt is equal to 1 by 2 theta square plus theta minus 3 e raised to power 3t. So in case of exponential, we are replacing d by a, and here we replace theta by a. And what is a? A is a coefficient of x in this case. Now it is a coefficient of t in this case, that is equal to 3. So substitute theta is equal to 3. So we have 18 into this term. So finally the general solution is equal to y of t is equal to c1 e raised to power t plus c2 e raised to power minus 3 by 2 into t plus 1 by 18 e raised to power 3t. Since we have the question in terms of x, so we need to write the answer in terms of x instead of t. We need to replace e raised to power t by x. Or if there is a t, we can write it as log of x. So in this case, final answer is equal to c1 e raised to power t is x plus c2. So e raised to power t is equal to x. So this is x raised to power minus 3 by 2 plus 1 by 18 e raised to power t is equal to x. So in this case we have x cube. Let's take another example. Find the general solution of the following equation. So in this case, step is same. First, on the non-homogeneous function, we will replace x with e raised to power t along with the term x into first order derivative as dy and x square second order derivative as theta into theta minus 1 into y. Substitute these values over here. So we have theta into theta minus 1 into y plus 5 times of x into first order derivative as theta y plus 3y is equal to log of e raised to power t. So this is a log with base e into e, that will give you the 1, and finally we have in this case is equal to t because this value is equal to 1. Simplify this term, theta square minus theta into y plus 5 theta y plus 3y is equal to t. This is further is equal to, collect the coefficient of y. So we have theta square minus theta plus 5 theta is plus 4 theta plus 3 into y is equal to t. Now if you replace theta by d, we have in this form. So in this case, we need to find the solution as complementary function as well as a particular integral. So same procedure we are going to follow over here, but instead of x we have t and instead of d we have theta. Now calculate complementary function. So for complementary function, we will write the auxiliary equation. So auxiliary equation, theta is replaced by m. So we have m square plus 4m plus 3 is equal to 0. So what are the roots in this case? Roots are minus 1 and minus 3. So final complementary solution in terms of t variable is equal to c1 e raised to power minus t plus c2 e raised to power minus 3t. Now find the particular integral in this case. So for particular integral, ypt is equal to, take this factor in a denominator, we have this form. So it is a polynomial case rather than t. If you think about the x, now it is get converted into the polynomial case. So in case of polynomial, we are taking the lowest power of d outside in this case. Now in this case we will take the lowest power of theta outside. Starts from the constant. So take constant outside, we have 1 by 3 into 1 plus theta square plus 4 theta by 3 into t. Now we'll take this term in a numerator. We have this form. Apply the expansion 1 plus x raised to power minus 1. This is equal to 1 minus x plus x square minus x cube and so on. Now when we are operating theta on this one, so theta stands for the derivative with respect to t. This implies theta into t means derivative of t with respect to t is 1. So what is the value of theta square t? That will be 0. And if we take further derivative, again it is a 0. So it means we don't need the term as a x square in this case. Or if you are going to operate this square on t, it is getting a 0. So first we expand this one. After expanding, we have this form. So x is theta square plus 4 theta by 3 plus x square. Now multiply these terms. 1 into t, that is a t, minus theta square plus 4 theta by 3. When multiplied by t, we have these two separate terms. One is theta square into t divided by 3 plus minus 4 theta into t by 3. Then next term is automatically getting a 0. So we have not written in this case. After that, simplify this. Theta square t is 0. Theta t is 1. When you substitute these values, we have this form. Simplify this, we have this polynomial. Journal solution is equal to complementary function plus particular integral. In this case, complementary function is c1 e raised to power minus t plus c2 e raised to power minus 3t plus particular integral is 1 by 3 t minus 4 by 3. Now we need the answer in terms of x, where t is replaced by log of x, or we can say that e raised to power t is replaced by x. So this is equal to c1. This term is equal to x. So x raised to power minus 1 plus c2. This term get x. So it is x raised to power minus 3 plus 1 by 3. So the value of t is log of x minus 4 by 3. And that is the final general solution in this case. Find the solution of this differential equation. Starting step is replace x by e raised to power t in a non-homogeneous function and x into first order derivative as theta y, x square second order derivative as theta into theta minus 1 into y. Put these values in this differential equation. After that, we have this form, and then we have collected the coefficient of y. Now, this is a differential equation with a constant coefficient. Find the complementary solution. For that, we will write the auxiliary equation, and the auxiliary equation is m square minus 6m plus 13 is equal to 0. And in this case, the roots are 3 plus minus 2 iota. And finally, complementary solution in terms of t is equal to e raised to power 3t into c1 cos of 2t plus c2 sine of 2t. Now find the particular solution. For particular solution, we will write this operator in the denominator form. So we have this form. Now it is an exponential case. So in case of exponential, we replace d by a, but in this case it has a theta. So theta is replaced by a, where a is a coefficient of t in this case, that is the 2. So replace theta by 2. We have 2 square minus 12 plus 13 is equal to 5 into 30 times of e raised to power 2t. Simplify this, we have 6 e raised to power 2t as a particular integral. So final general solution in terms of t is equal to e raised to power 3t into c1 cos of 2t plus c2 sine of 2t plus 6 times of e raised to power 2t. So final solution in terms of x variable. So we replace e raised to power t by x. And in this case we have x cube over here. C1 cos of twice of t is replaced by log of x plus c2 sine 2 times of log of x plus 6 e raised to power t is replaced by x, so we have x square in this case. And that is the final answer for this question.